Today, we're going to talk about how to solve rational equations. Rational numbers are numbers you can write into fractions. If you have equations, you have rational expressions involved, like this one, 3x plus 5 over 3x. Then you'll have a rational equation. Before we get into how to solve that, let's review some basic stuff. So get us ready to tackle this problem. Okay, let's first take a look at how to solve for x in a simple proportions. So x over 25 is equal to 2 over 5, 2/5. That's a simple proportion. And we could solve this equation because that is an equation. You can't solve something that's not an equation. So hopefully we know that already. And therefore, this is addition, the sum of two fractions, difference of two fractions, product of two fractions, and division. I was meant to put in the division there. So those lacking of a equal sign, they're not equations. So you cannot solve for x. You will not get x equal to something. You can add them, you can subtract them, you will get a different expression. Okay, so let's just make that clear. So this is a proportion. So let's hopefully you know if you have a proportional, you can do cross multiplication. All right, let's get into how to do that. So if you see a problem like this, first recognize one fraction equal to another fraction. You have a simple proportions, and you can cross multiply. So 5 times x is 5x. 25 times 5 is 50. Then you want to further isolate x, undo the multiplication. 5 is multiplied to x. Simply undo the multiplication by division. Divide by 5 on both sides, and you have solved this. So 10 over 25 is the same as 2 over 5. So they're proportional. Okay, so now we know how to do solve simple proportions. We can move on to how to solve linear proportions. Okay, so instead of just simply 5x there, we might have expressions involving a linear expression. That's like a slope-intercept form almost, if you look at that. Okay, so one linear expression over another linear expression. So recognize those are linear proportions. How are we going to tackle that? As long as you have a fraction equal to a fraction, you can always carry out the process of cross multiplication. So again, 6 times 2x minus 6 is equal to 7 times x plus 2. Do put a parenthesis there. What if you put this on the left-hand side and this on the right-hand side? Would that be okay to do? Absolutely. And that does change. That changes nothing. They're exactly the same. They're equal to each other. Okay, next thing you want to do is do the distributive property. So basically everything inside this parenthesis will get 6 times bigger. So it was 2, 6 times bigger, 6 times 2x, you get 12x. 6 times a negative, be careful, there's a negative sign there. So the product is negative 36. Right-hand side is just simply everything turn into 7 times bigger. 1x becomes 7x. 2 7 times bigger is 14. And you put all the variables into one side. So the easiest thing to do is subtract 7x. And you did that. Now all x on the left-hand side. You want this negative 36 to disappear because you want to isolate the x. So put its opposite up. So negative 36 put together with positive 36 will cancel each other out. On the right-hand side, you just add those. 14 plus 36, you get 50. Again, now that's pretty straightforward. Just divided by 5 on both sides. You get x equal to 10. That's your final solution for this problem. Okay. It's pretty much like the simple proportionals, but just with a linear expressions on both sides. Next, we still have a fraction equal to another fraction. However, this time it's getting a little bit more exciting. And as you realize, if you do cross multiplication, you will have a quadratic expression here. Okay, so let's get started. So solving quadratic proportions. We'll have to use your ability and solve quadratic equation here. Okay, so recognize that's a fraction equal to a fraction. It's a rational equation. Cross multiply. So x times x minus 1 is equal to negative 6 multiplies, parenthesis, x minus 4. Distributive property, x squared minus x is equal to negative 6x plus 24. So negative 6 times negative 4 is positive 24. So now this is, you need to recognize you have a quadratic equation on your hand because you have x squared. The highest degree is 2. So you want to have this ax squared plus bx plus c standard form on the left-hand side. So just bring everything to the left-hand side. Add 6x minus 24. Line up the like terms. 6x and negative x are like terms, so put like terms together. You don't have a number there, so just leave a space and bring the 24 over here, minus 24. So the right-hand side cancels out, opposites cancel, equal to 0. Left-hand side, you have x squared plus 5x minus 24. And as you know, this is a quadratic trinomial. And the fastest way for solving a quadratic equation is by factoring. So let's see if we can factor this. And lo and behold, it could. And because, doing a FOIL, x times x first has to be equal to x squared. So immediately, x goes here, x goes there. And we have done this so many times in my class. You're looking for two numbers. Multiply the two numbers will give you this last term of minus 24. And combine the two numbers together should give you the middle coefficient, positive 5. So we have found it. Negative 3 times 8 is negative 24. Negative 3, positive 8 combined together gives you a positive 5. So if you multiply this together, you will get this trinomial back. So you know you factored correctly. Now, you use the principle of zero product here. If this is equal to 0, 0 times the second expression will equal to 0. Or if the second factor is equal to 0, would also satisfy this equation. So simply solve this one. 3 minus 3 equal to 0. So x got to be equal to 3. Negative x, positive x, cancel. So x for the second equation is negative 8. And therefore, we have solved this quadratic rational equation. Okay, so we have now did all the preparations for tackling a problem and look like this when we first looked at it. Now, you notice this one, you have actually three rational expressions, one fraction, another fraction, and another fraction. So if you think back, if you multiply 3x here and 3x and will cancel out. So what you need to do is you need to find the least common multiplier. And just think about this. And 3x. So 3x times 1 is 3x. And 3 times x equal to 3x. And therefore, 3x is the least common multiplier. If you're not sure what to do, just multiply some of those denominators together. If they equal to the third one, then you have found your least common multiplier. So once you determine the least common multiplier, and you can quickly multiply the least LCM to both sides. And you did that. Remember, you multiplying 3x to the first rational expression. You're also distributing that to the second rational expression. So every fraction gets to be multiplied by this lowest common multiplier. And you will see it's pretty very good strategy. So 3x cancel out. 3x and x simplify. You would just have 3. Okay. And here, and 4 times 3x divided by 3. And if you did that, the first term just turned into 3x plus 5. Here the x's cancel, turn into negative 3 times 3. Here the 3's cancel. You'll have 4x. And you actually have wound up with a very straightforward linear equation to work on. So combine like terms, pick out the lower hanging fruits first. So you have 3x minus 4 equal to 4x. You want all the x variables to one side. So subtract 4x from both sides. Just make sure you put the like terms together. Don't put this under the negative 4. And simplify. 3x minus 4x is negative x. Carry down that. Then add 4. Move the numbers to the other side. And if opposite of x is equal to 4, you can do mental math, and you realize that x is equal to negative 4. So this, we just gone through step-by-step process on how to solve a little bit complex rational equation.